Question 2. Crystal violet C25H30N3Cl is a purple dye. Some light is absorbed when it's passed through the dye solution. So from here we know that the complementary color will be absorbed. So the complementary color for the purple is yellow. So means yellow will be absorbed, and we mostly will see the purple. Okay, absorbance is proportional of the light absorbed at the particular wavelength. This measured using the colorimeter. Okay, this is the absorption spectrum. So the peak maximum is around 580 to 590. So later we get back to this absorption spectrum. Let's start some theory of this colorimeter. Okay, so this one is a colorimeter, and this is a place for to put the sample. Let's say now we have a purple solution. We put inside the meter. So it started with the full light spectrum, and we can select certain wavelength in the meter, and let this color or let this wavelength pass through the solution. So because the purple solutions most likely we will absorb the yellow color, so we will choose the yellow color wavelength, which is in the range of 570 to 590 nanometer. So that's why the peak maximum is around this area, because the yellow color is being absorbed here. So absorbent more means this color means this yellow color is being absorbed more. That's why we should choose this wavelength, because this wavelength easily absorbed by the purple solution. Okay, and again, let's use back this one. When we choose the specific wavelength, like yellow color will pass through the, let's say, the solution. Okay, purple color. This is a sample holder. Inside the sample holder, there is a solution. And the solution will absorb this wavelength, and the detectors will tell us how much of this wavelength or this light being absorbed by showing the absorbance here. Means when the purple solution is more intense, means more purple color, it will absorb more yellow wavelength or yellow color, and the absorbance will be higher. Again, when the purple color is more intense, it will absorb more yellow color, more complementary color, and the detectors will tell us how much of this light being absorbed. Higher absorbance means is higher concentration of the color solution. Okay, there's a theory behind that. Okay, so let's get back to this question, this absorption spectrum. That's why we should choose the wavelength around this range, about 570 to 590. But according to this absorption spectrum, you should choose the wavelength in this range, 580 to 595 nanometer. Means when you put any value within this range is acceptable. The answer in the mark scheme is 588 nanometer. Okay, so again, a student investigate how to determine the concentration of aqueous crystal violet using this meter. Suggest the best wavelength of the light used in the colorimeter. So again, we must refer to this maximum. So the range is about 580 to 595 nanometer. Part B. Solution D is 500 cm cube of 2.5 times 10 power negative 2 mole per dm cube of this dye solution. Calculate the mass of the dye that needed to prepare this solution D. This is quite easy. First, you need to find because it needs the mass. So we first need to calculate the mole. So using the volume of the solution and the concentration, okay, mv over 1000, so we get 0.0125 mole. And use the molar mass that given here, 407.5 times the mole, you should get 5.09 gram. So the mass that needed is 5.09. We need to use this mass for the preparations later. Okay, part 2. The student is given a small pickle containing the mass of this dye calculated in part 1. Describe how the student should prepare 500 cm³ of the solutions D. Include the name and the capacity of the key apparatus which should be used, and describe how the student should ensure the volume is exactly 500 cm³ or 500.0 cm³. Okay, so first, because this is the solution preparation using a solid, we must start from the solid. Okay, we put 5.09 gram of the purple dye into a small pickle. After that, we need to add a small amount of distilled water. It must be distilled water to dissolve the solid. Once the solid fully dissolves from the solution, we pour the solutions into the volumetric flask. It must be 500 cm³ because we need to prepare 500 cm³ solution. Okay, of course, after these solutions are poured from the pickle to the VF, so we need to rinse the pickle a few times, make sure all the compound get into the VF. After that, we need to top up to the calibration mark and homogenize the solution. Okay, that's a step we need to do. Okay, this is the full answer for the steps. Okay, add small amount of distilled water to the small pickle to dissolve the 5.09 gram of the purple dye, the crystal violet. So you must put this gram because it's asked specifically what are the capacity and as well as this mass. Transfer the solution. Okay, once it dissolved, transfer the solution, rinse the pickle with distilled water and pour the washing through the funnel or using funnel into the 500 cm³ of the volumetric flask. After that, make up to the calibration mark using distilled water. This part must be there. We must top up to the calibration mark using distilled water. After that, put the stopper, invert and shift to homogenize the solution. So these are the full steps. Part C. A small sample of solution D, okay, with this concentration, was diluted to form solution E. Much dilute to form this concentration now. The student prepared solutions 2 to 6 as shown in table 2.1 here. The total volume need for each solution 2 to 6 is 20 cm³. Okay, so this is a key. Each solution is placed into the calorimeter and the absorbance is measured. So means the absorbance is shown here. First, you need to fill up this part or calculate this part. So this one is a solution E with this concentration. Now, we need to prepare a new solution with all this concentration. The first one, no need. What you need to calculate is from 2 to 6. Okay, I will show you one calculation, then you can use the same calculations for the rest. Okay, let's use the solution 5. If we want to prepare this concentration, 2.00 times 10.84 mole per dm³ from the solution E. So first we must, because it's a dilution, we must use M1V1 equal to M2V2. Okay, M1 is the concentration for the more concentrated solution, solution E in this case, solution E. V1 is the volumes that we need to take from solution E. Okay, M2 is a concentration that need to prepare. in this case, solution 5 is 2 times 10 power negative 4. Here, total volume that need to prepare is 24. From 2 to 6, all same, is 20. So bring this concentration to right, then you get this. So eventually, after calculation, the volumes that need to be taken from the solution E is 16. So means here you must put 16. When this is 16, volume of water must be 4 because total must be 20. So this is a calculations for this table. You just follow this calculation. If you want to make it fast, you just use this ratio lah. This one, 20 over the concentration of the solution E. Okay, times the concentration that need to prepare, you get the volumes. Okay, so just calculate and fill up this table. Okay, these are all the answer. And part 2, identify the dependence variable. Dependence variable is absorbance. Why? Because when we change the concentration of the solution, when the concentration of this crystal violet is different, you see, when we use different volume, when the concentration different, the absorbance will follow. More concentrated solution will have higher absorbance, as you can see here. So again, the dependence variable is the absorbance. Independence, of course, is the concentration. We can prepare different concentration. Part D1. Plot a graph of absorbance against the concentration of the dye solution in this figure 2.2. Draw a straight line of best fit. So this is easier. Sometimes it's because some of the question is it might be curved. The instruction now is very clear. It's a straight line. Okay, so you just need to plot. Use the values again. Absorbance is already given. Concentration also given. So means basically you need to use this value, right? The concentration versus this absorbance. Okay, so you should get these graphs. Okay, make it okay, easy to see. So you should get something like this, right? So absorbance versus the concentration of the dye solution. So make sure it's passed through the origin, and it must be balanced. Means try to pass through as many plots as possible, and it must be balanced. Okay, so after that, we will find the abnormalist point. We'll discuss that later. Right, so again, it's the best fit line from origin, something like this. Okay, you can try it out. Okay, next part. Okay, part 2. Circle the point on the graph you consider to be the most abnormalist. Suggest one reason why this abnormality may have occurred during the experiment procedure. Okay, assume no error was made in the measurement of absorbance. Means the meter is fine, no problem. So let's look at the abnormalist point. Okay, if according to this best fit, so for this concentration, 1.00 times 10^-4 mole per dm cube. At this concentration, the absorbance should be somewhere here, about 3.5 lah, we can say. So for this one, it's supposed to be around 3 point something or 3.5, but now it's lower. It's about 2 point something. Why? Means the concentration is lower than expected. Why the concentration is lower than expected? So there are two reasons. You can just give one. Okay, first, okay, because the volume of distilled water added is too large. More distilled water added, the solutions will become more dilute. Means the concentration is not there. Or you can say that the solution E that added is too small. So you just choose one of them. And these two will cause the concentrations to be lower. Okay, part 3. State the relationship between the concentration and absorbance. From this graph is quite clear because it's a best fit line and it's from origin. We can say that the concentration of the dye solution is directly proportional to the absorbance. Part 4. Suggest how the student could improve the reliability of the data obtained in the experiment C. This one is very easy because this solution 3 is abnormalous. We just need to repeat that. Right? Repeat the experiment. We can get the correct readings. Part E. The student carry out a further experiment to examine the kinetics of the reaction between the crystal violet and the aqueous sodium hydroxide. So this is a reaction equation. Hydroxide with the dye will form this compound, these two compounds, which means after reaction, the purple's gone. The purple color will be less intense. The disappearance of purple color as the reaction proceeds may be monitored by the colorimeter using the absorbance. The student mixed 5 cm cube of the solution with 5 cm cube sodium hydroxide. Okay, hydroxide is in large excess. And immediately start the stopwatch. Okay, after mixing, start the timer. And the resulting mixture is placed into the meter and the absorbent is being measured every 100 seconds. So this is the graphs that produce is already in the question. What you need to do is just to choose the coordinates. So this is the result that produce absorbance versus time. Every 100 seconds measure one time. So this curve produce. Now let's see what is the question. Suggest why it's not possible for the student to measure the absorbance of the mixture at the time equal to 0 seconds. Of course it's impossible, right? So because at time equal to 0 seconds, the solution is just being mixed. So it's impossible to measure the color change immediately. It will take times. And to put into the meter and for the mixture to react, right? So this is a standard answer. Okay, part 2. Use the graph to find the half-life starting at 100 seconds. State the coordinates of both points of the line of best fit used in your calculation. So half-life, you need to know, is the time that taken for the concentration or the absorbance in this case to reduce half. So means in this graph we need to find, okay, make it smaller. Okay, because start from 100 second here, right? So the absorbance is around 0.36 here, 0.36. So we need to find the time or the coordinates which the absorbance reduce half. So the absorbance at 100 seconds is 0.36. Half of this value is 0.18. So 0.18, and of course it must from this line. So 0.18, so we can get this coordinate. So the time is 315 seconds. So these are the two coordinates you must use to compare. So means from 100 seconds to 315, the half-life is 315 minus 100, so it's 215 seconds. So this is the time for the absorbance reduced half from 0.36 to 0.18. Okay, so these are the two coordinates that you must choose. It should be same for all, 215 seconds. Okay, last one. Another student repeats the experiment at a different temperature and measure the two half-lives value. The values obtained, they are 420 second and 425 second. Use these values to deduce the order of the reaction with respect to the dye solution. It's quite obvious and easy because the half-life now is quite close. It's about 420 something. So we can conclude that this is the first order because the half-life is constant, is almost constant, very close. When the half-life is very close or constant, so we can say that the order is first order. So you should learn this one in the kinetics, in this paper 4. Okay, that's all. Thank you.